Hi guys, 11.5 we're talking about direct variation. Direct variation is basically there's a direct relation between two different numbers. So for direct variation, two variable quantities are related proportionally by a constant positive ratio. What that means basically is that for let's say for instance, for every number of shirts that you buy, let's say you buy one shirt, two shirts, three shirts, the amount of the price that you pay is gonna go up, right? If you buy one shirt, it may be, let's say, $10. If you buy another shirt, it'd be 20. If you buy another shirt, it'd be 30. This is direct variation. The number of shirts directly varies with the amount of money that you pay. Okay, so the more that you buy, the more that you pay. That is a direct variation. Now, for our formula here, it's y is equal to kx. Y is equal to kx. K is our constant, okay? K is our constant. It always stays the same. So for example, when we say determine whether a set of data varies directly, we're going to take a look at this data and we're going to try to see is there a relationship between the US sizes and the European sizes. Is there a direct relation? The way to compare a set of data is to make a ratio. I'm going to make a ratio of European sizes to US sizes. So let's say for instance 39 over 7. So European size over US size over European size. And I'm going to set that equal to, let's say, this one over here. So 45. So European has to stay on stop over American. I'm going to multiply 39 times 11, which is 429. I'm going to multiply 7 times 45, which is 315. These are not the same numbers, so this is not directly varied. It's not the same ratio. So this is not direct variation. Let's look at a second set of data, and we're going to go ahead and check to see. I'm going to make it distance over time. So 350 over 1, is that equal to 700 over 2? We're going to cross multiply. 350 times 2 is 700. 1 times 700 is 700. These are equal, so this is directly varied. Okay, that means it goes up by the same number. And if we check here, we see it goes up by 350, it goes up by 350, it goes up by 350. So there is direct variation. Now, one of the things that we're going to do here is we have to find each equation of direct variation given that y varies directly with x. So the equation that we need to know again is y is equal to kx. Okay, that's our equation. Now it says here when y is 52, when x is 4. And we want to find out k. And actually this is really simple. All we have to do is plug in 52 for y equals k times 4. Now we want to get k by itself to figure out what the direct variation is. To get k by itself, we're going to divide by 4. And we're going to find out that k is equal to 13. So we have to find the equation. So the equation is going to be y is equal to 13x. Okay, so you look for k and you plug it in when they're asking you to figure it out. Here's another example. Find out when x is 10, when y is 15. So when x is 10, y is 15. To get k by itself, we're going to divide by 10. So k is equal to 15 tenths, which is the same thing as if we divide by 5, we get 3 halves. So y is equal to 3 halves x. I want you to try this one by yourself. Find out what the direct variation equation is when y is 5, when x is 2. So y is 5, when x is 2. We divide by 2, we get 5 halves is equal to k. So y is equal to 5 halves x. This would be our answer for this one. Alright guys, I hope you guys kind of understood that. It's not too bad, right? The main thing we do have to remember is that y equals kx is our direct variation equation. Sometimes they'll give you y and x, sometimes they'll give you k and x, so just make sure you plug in the correct numbers. Don't forget to do your homework tonight, guys. It is a worksheet. Make sure you guys do that and turn it in tomorrow. I will see you guys tomorrow, so you guys should be listening to this hopefully on Wednesday.